Hello everyone, this is Ashish and welcome to Infinity Learn by Sri Chaitanya YouTube workshops. Now, as I discussed yesterday as well, that we'll be coming with different sessions, different workshops on all the 3 and 4 subjects. 3 for JEE and the other 3 for NEET. For JEE, I will be talking about physics, chemistry and maths. So for this, you need to subscribe our YouTube channel so that at the end you get all the updates about all these workshops for physics, chemistry and maths. And if you are also interested in the NEET, or if your friend who is preparing for NEET exam, then you can also subscribe our channel for NEET. There we would be discussing about physics, chemistry and biology. So now in this particular session, we would be entering into the world of probability, right? Probability is one of those interesting area similar to permutation and combination, and it is a continuation of PNC only. Probability, as I see probability is basically 2 PNC problems. One, where you have to find out the number of ways without the constraint, one with the constraint. With the constraint, it becomes your favorable cases. Without the constraint, it becomes your total cases. And probability of any event A, as we all know, will be given by favorable cases upon total cases. Hence, I normally say probability is a continuation of PNC. So at the end, we just have to solve the problem in 2 different ways. Total cases and favorable cases, the proportion will give us the probability. So now without wasting any more time, right, let us jump into the world of probability and we would be solving previous year questions. So stay with me guys and let's move on to question number 1. The question number 1 says, out of 11, my bad, let's pick a pen and a color. So let's have green today, right? So out of 11 consecutive natural numbers, if 3 numbers are selected at random, right, then the probability that they are in AP with a positive common difference. Now what do you mean by a positive common difference? In an AP we have studied, if the common difference is positive, the AP would be an increasing AP, right? The terms will be increasing in magnitude. For example, 2, 4, 6, the terms are increasing. If your common difference is negative, then you have a decreasing AP, right? 6, 4, 2 is a decreasing AP, right? The common difference is minus 2. So now over here the question says we have to just focus upon the increasing APs, not the decreasing ones. So now we'll find out the probability. So I need 11 consecutive natural numbers, right? Now probability is basically a proportion, right? So it depends on the sample space. Right, so in a sample space, the proportion, right, will always be same. I'll explain what I'm trying to convey to you right now, because this understanding is also important. Let's say if I mix 5 liter of water into 10 liter of milk, if I mix, I'll get a 15 liter of a mixture. The ratio of milk is to water would be 2 is to 3 or 1 is to 3, right? Now if I take out a sample from that mixture, and if I find out the ratios would once again be 2 is to 3 or 1 is to 3, depending upon you are calculating the ratio of water is to milk or milk is to water. So if I take out a sample, my ratio will never change, my proportion will never change, right? Probability is a proportion. So if you take out a sample from a homogeneous mixture, then also your probability will be remain same, it will not change. So over here I am talking about 11 consecutive natural numbers. So I can take any 11 consecutive natural numbers, my probability will not change. So I am considering 1 to 11 over here for our simplicity. तो अभी क्या करेंगे अपन, numbers assume कर लेते हैं. मान लो ये 11 natural numbers आपके पास है. Now I have to first find out the total number of ways. फटाफट से everyone. What is the total number of ways? I have to select 3 numbers out of the 11 numbers. So selection of 3 out of 11 is nothing but 11C3. Total ways is there. Now I have to count the favorable number of cases. For favorable, I have a constraint that the term should be in AP. Now AP, the APs would be defined by the common difference, right? So I will make the cases according to common differences. So the first possibility can be common difference is 1. Now if common difference is 1, then I have to find out how many 3 numbers are possible with common difference 1 and they are in AP. So I will list down over here. So common difference 1, it is 1, 2, 3, the smallest 3 natural numbers. Then I can have 2, 3, 4. Then I will have 3, 4, 5 and so on. What will be the last one? So the number should end at 11. Subtract 1, subtract 1. So I would be writing 9, 10, 11 would be the last three numbers which are in AP with common difference 1. Now you see how many APs did I got? 1, 2, 3 till 9. So I can look at the first numbers and I can say there are 9 APs. So when D is equal to 1, we will have 9 cases formed where the numbers are in AP and common difference is 1. Now I'll talk about the D is equal to 2. Now if D is equal to 2, the smallest AP would be 1, 3 and 5. Then 2, 4, 6, right? What will be the last one? Last one would be 11. Take a difference 2, 9, 7. So how many APs we got over here? Look at the first number 1, 2, 3 till 7. So I know 7. So when D is equal to 2, we got 7 APs over here. Now let us find out for D is equal to 3. So now you know the approach. Let us try to find out for D3. So you will have 1, 4, 7. Last would be 11, 8, 5. So how many APs we got? 5, right? The first place is 1, 2, 3, 4, 5. Do you see a pattern over here? 9, 7, 5. So I know when D would be 4, I will get 3 APs. When D is equal to 5, I will get 1 AP. Let us just check, right? D is equal to 5. Just to cross check कि जो अपन ने किया यहाँ पे वो सही है कि नहीं है. So if the common difference is 5, I'll get only 1 AP. Let's see, 1, common difference 5, 6, 11. If I start with 2, then 2, 7, 12. 12 is not available. So I know there is only one possibility. So these are the different 3 numbers which are in AP with different common differences. So some of them would be my favorable cases. Let's add all these. 9 plus 1, 10, 7 plus 3, 10 plus 5. So sum would be 25. So I can write the favorable case or favorable ways are how many? 25. Now what is your answer? Your answer is favorable outcomes upon total outcomes. So my answer would be 25 upon 11C3. Now do I see 25 upon 11C3 over here in the options? No, right? These are the fractions. So we will simplify this. 25 upon 11C3, factorize it, right? Using the technique that I have taught you in the lecture of P and C, right? 11C3, so it will be 11 into 10 into 9 upon 6. So I will have 25 into 6 upon 11 into 10 into 9. So 3 2s are, 3 3s are, 2 5s are, 5 5s are. So numerator is 5 and denominator is 33. So where is 5 by 33? Option number 3rd is your correct answer, right? So I hope this example is clear to everyone. Subiksha, good morning, right? Hello. So now we'll try the question number 2. If 10 different balls are to be placed in 4 distinct boxes, observe carefully guys, यहाँ पे different, यहाँ पे distinct, right? So they are synonyms. So ball भी different है और boxes be distinct hai. So Biksha, you are a new student. Okay, so I can welcome you to this particular platform of Infinity Learn. In this particular session we are talking about probability. So stay with us and whatever doubt comes to you, right, you can always post there. I will reply to you. So now 10 different balls are to be placed in 4 distinct boxes. We have to find the probability that 2 of these boxes contains exactly 2 and 3 balls. Right? Now let us understand this. Now the question says, right, because comprehension is important. If you have comprehended the question correctly, getting a right answer will not be difficult for us, right? Most of us make some mistake, right? We don't comprehend the question completely. We jump into the solution that I need to find out the solution minimum time. Spend your time in comprehension. 10 seconds spent in the comprehension will save 5 minutes wasted in the calculation, right? So now in this particular example, where was I? I have 4 distinct boxes. Distinct means I can differentiate between them. So why not let's name them A, B, C, D. So we have 4 distinct boxes. Now I know 2 of these boxes will have 2 balls and 3 balls. Now the very first thing that comes in our mind is, right, which of these 4 will have 2 and 3 balls? Answer is B. I have no idea. I also have to check, right? So now we'll select 2 boxes from here. So I am calculating the favorable cases. First, I will select 2 boxes, 4C2. The 2 boxes out of A, B, C, D, where I will put the 2 balls and 3 balls. Let's say A and B are being picked, right? Now, out of these 2 boxes, we have to pick which one will have 2 and which one will have 3. So the selection of box with 2 balls is 2C1. Now, I have selected only the boxes, right? So, Bhiksha, I have to distribute the balls now. How many balls do I have? 10. Now I have to pick 2 balls and have to drop in one of these boxes. So I will select 2 balls out of 10C2. Now I am left with 8 balls. Out of 8 balls, I have to select 3 and put it in the other box. So let's say after this box got 2, this box got 3. So 5 balls are already being filled. You are left with 5. You are left with 5 balls more. And there are 2 boxes. You can fill in these boxes by any number of balls. So for the first ball, there are 2 options. Second ball, there are 2. Similarly, third ball, fourth ball and fifth ball. This is the favorable case. I'll divide this by total cases. What is the total case? For every ball, I have 4 options. So 4 into 4 into 4, 10 times. So if you simplify, 4C2 is 4 into 3 upon 2 into 2. 10C2 is 10 into 9 upon 2. 8C3 is 8 into 7 into 6 upon 6 into 2 raised to power 5 whole divided by 4 raised to power 10 is 2 raised to power 20. Right. So we can simplify this. 2, this gets out. 2, 3, 6. Right. So now we are left with all these values. So this is 1, 2, 4, 9, 10 2s are out. So we are left with 2 raised to power 10. So this is your answer, 9 into 7 into 6 upon 2 raised to power 10. Right guys? Right? So now 5 is also there. So 9 into 7 into 6 into 5 upon 2 raised to power 10. You can simplify this, whatever it will be your answer. Let us move on to the next example. The next example says S is a set from 1 to 20. A subset B of S is to be said nice if sum of the element is 203, right? Find the probability that the randomly chosen subset of S is nice, right? And the question is also nice, right? Over here you have to use a slide of your observation. See, there is a set which is given as all the elements from 1 to 20. Now I have to make subsets. First of all, let us calculate how many subsets we can make. Total number of subsets. Now for any subset, right? Subset is a set formed by sum of the elements. So if I have to make a subset, now for the first element, I will have 2 thoughts. I can have that one in my subset or it will not be there. So 2 ways. For the second element, either it will be there in my subset or it won't be there. So for every element, I have 2 options available. Either that number will be in my subset or will not be there in my subset. So 2 raised to the power, how many elements do I have? So 2 raised to the power 20 would be the total number of subsets possible over here, right? So if I find out the total number of outcomes in this particular case, total number of outcomes will also be equal to total number of subsets. So this is also equal to total outcomes. So one part is done, right? Or I can say half of the question is done. I have got the total outcomes possible. Now we have to find out the favorable. The whole story is hidden in the favorable cases. Now how do I calculate the subsets such that the sum is 203? Now I cannot do it manually, right? I cannot add numbers which make sum 203. I have 20 numbers. That would be really difficult for me to make sure that the sum is 203. There has to be something with this number, because in this particular question, it is not about adding the values. It is all about observing it. Let me change the color first. Right. So now, I cannot randomly add and check whether the sum is 203 or not, right? Now 203 is a very big number and I have small natural numbers. let us do otherwise. Let us try to find out the sum of all natural numbers. So if I take all the natural numbers from 1 to 20, what will be the sum? Remember sigma n, where r goes from 1 to n. This is n into n plus 1 by 2. Right? You might have learned this particular property or a formula when you were doing sequence and series. So I can use same over here. 1 से 20 तक का sum निकालने के लिए we'll put n to be 20. So 20 into 21 by 2. What is the sum? Okay, now we are getting the logic. The total sum is 2110. I have to find the sum 203. So if I take all the numbers from 1 to 20, the sum is 2110. But the question says find the sum 203. So in short, what I have to do? Out of these 20 numbers, I have to remove some numbers such that their sum should be 7. For example, if I remove 7 from here, so I will get 1, 2, 3, 4, 5, 6, 8, 9 and so on. The sum of all these numbers would be what? 2110 minus 7, 203. Right? So if I can remove some numbers such that their sum is 7, then my job would be done. Now in how many ways I can remove numbers whose sum is 7? Sum is 7 is easy to calculate. Sum 7. So I'm writing the case over here. Either you can remove 7, or let's say if I remove two numbers, then 1 6, 2 5, 3 4. Their sum will also be 7. Can I remove three numbers? 1, 2, 4, right? Is there any other possibility with three numbers such that their sum is 7? No, right? 4 numbers, sum will be more than 7. So now we have no other possibilities. These are the possibilities of getting a sum 7. 1, 2, 3, 4, 5. So now from 1 to 20, if I remove 7, the sum would be 203. From 1 to 20, if I remove 1 and 6, the sum would be 203. So how many such pairs will I get whose sum is 203? 5. So can I say my favorable cases is nothing but equal to 5. So from here, I can tell my answer is favorable case upon total number of case. So 5 upon 2 raised to power 20, that is option B. Right? So for this particular example, the option B is the correct answer. Right? Let us move on to the next example now. देखो next example once again interesting. Whatever examples I have picked over here for this particular workshop, right? They might can be from the JEE Main, happen in the recent time 19, 20, 21. They might can belong to the online papers of JEE or some previous, the old papers of JEE. But every question comes with a concept which is more important as far as examination is concerned. Just make sure by the end of this particular workshop, you are clear with all these concepts. If you are clear, no matter what problem comes inside your exam, I am pretty much sure that you will be able to crack it and you would be gaining plus 4 marks. So this example, okay fine. So now we have two families A and B, right? Once again, we'll comprehend the problem first. Probability we have to comprehend first. There are two families A and B blessed with equal number of children. Number of children is not specified, but they are equal. Okay, so there are 3 tickets to be distributed among the children of these families so that no child gets more than 1 ticket. So in short, I have 3 tickets I have to distribute. So the children will either get 1 ticket or they will not get any ticket. So there are only 2 possibilities. The probability that all the tickets goes to the children of family B is given as 1 by 12. So I know one probability. What is being asked? Number of children in each family. Okay, so जो हमसे पूछा गया है, we'll assume that to be x, right? In this particular case, number of children in each family, so I'll assume it to be x. So now both these families, let's say family A and family B. Now both these families have x kids, and now we have 3 tickets. Now think of all the possibilities that is possible over here, right? When we are distributing 3 tickets, because that will define my sample space. Sample space is all the possibilities. So now family A, family B, I have 3 tickets. The first possibility would be 3 tickets goes in the family A, 0 goes in the family B. Second, 2 goes over here, 1 goes over here. Third, 1 goes over here, 2 goes over here. 4th, 0 goes over here and 3 goes over here, right? So these are the possibilities. I know one probability. The probability that all the tickets go to the children of family B is 1 by 12, right? So let us find out the probability that 3 tickets goes to B, right? So now see over here, all these possibilities, right? If I combine, I have 2x students or 2x children. If I pick any 3 children out of 2x, all these 4 possibilities will be over there, right? So what I am doing is 2x C3. So all the children together and you are randomly picking 3. So it is possible that you get 3 from the A. It is also possible you get 2 from A and 1 from B and so on. So total probability is 2x C3. Sorry, the total cases over here. You got the total outcomes? Now we'll talk of the favorable outcomes. What is the favorable outcomes? All the tickets go to the children of family B. Where is my family B? This is my family B. So all the ticket goes to the family B, XC3, right? You have selected 3 out of the X, right? Anyhow, I know X has to be larger than 3. Otherwise, I will not be able to select 3 students out of X. And this is equal to 1 by 12. Right? Now we have got the probability. Now it's just a matter of solving the equation to find out the values of x. So let us quickly solve this. Now XC3, right? In PNC workshop, remember last जो मेरा workshop हुआ था उसमें मैंने समझाया था NCR की value फटाफट से कैसे निकाल सकते हैं. So if you haven't watched that video, watch it, right? It's available on the YouTube only. So XC3 would be x into x minus 1 into x minus 2 upon 2x into 2x minus 1, 2x minus 2. This is equal to 1 by 12. So x will get out with x. If I take 2 common out of this, it becomes x minus 1. So this gets out and I am left with 2. So now let us cross multiply. I have x minus 2 in the numerator. This is 4 into 2x minus 1. If you multiply, it becomes 2x minus 1 upon 3. Right? 4 will cancel out the 12. Cross multiply 3, you get 3x minus 6 is equal to 2x minus 1. So from here I got x is equal to 6 goes over here. Your answer is 5. So where is 5? Option number 4 is the correct answer. Right guys? So we can move on to the next example now. The next example. A number x is chosen at random from the set, right? From these 100 numbers, you can select any number from it. Define the event A. The chosen number satisfies this, right? So it's a problem that has been asked twice in JEE, right? Now over here, I have to make a selection, right? Now before that, I have to simplify this, right? So for this inequation, we will use the wavy curve method. Rishabh, wouldn't we select one family? No, right? Because it was given that all the 3 students should be from family B, right? So anyways, we have moved to the next problem. You can rewatch the video. You will understand the logic, Rishabh. So first of all, we'll simplify this inequation to get the values of x. So wavy curve method says plot the roots. So 10, 30, 50. This is positive, negative, positive, negative. I am looking for positive. So x belongs to 10, 30 and 50, infinity. And there is a equality sign. Equality sign is for 50 and 10. So 50 I will have a close bracket, 30 I will have a open bracket and 10 I will have a close bracket. So this is my range, right? Now I have to find the probability of A. So what are the total outcomes possible? A number x is selected from this particular set. So total possibility is 100. Right. Now I have to find out the favorable. Favorable is event A is defined as the chosen number satisfy this. Right. Now A belongs to this particular interval. Right. Now how many numbers I have over here? I have from 10 to 30. Right. So 10, 11, 12. Till 29, 30 is not included, right? and then 50 to infinity, but I am talking about only 100, right? So 50, 51, 52 till 100. This is the complete set for my favorable outcomes, right? Now let us count how many of them are there. Now how to count them? I will take the difference. When you take the difference, right, one of the end will not be counted. If you have to count both the ends, you have to add 1. If you don't have to count the ends, you have to subtract 1. So if I take the difference, it becomes 19, but I have to count both of them. So I will add 1. So there are 20 numbers written over here. Now if I count over here, this becomes 50. I have to count both these numbers. So it becomes 51. 51 over here, 20 over here. Total becomes 71. So my answer would be 71 by 100, or basically 0.71. So your answer is option number A, that is 0.71. Right guys? So you guys are with me, है ना? कोई सोया नहीं ना अभी तक? Right? चलो. So we move on to the next example. Next example says there are 2 balls in an urn. Each ball can be either white or black. Right? Now comprehend this problem. It's a very interesting, it looks very interesting. There are 2 balls and the 2 balls can be either white or black. It is not given whether we have 2 whites or 2 blacks or 1 white or 1 black or whatsoever. So the composition of the box is not given to us. Now they are mentioning a white ball is put into the urn. ठीक है, white ball डाला अपन ने, and then after a ball is drawn at random from the urn. Okay, so we have added 1 white ball and then after we have picked a ball. Then the probability that it is white. Okay, so now before I move into this solution, right, over here I don't know the composition of the box, whether there are 2 white, 1 black or whatsoever. So I have to make the different cases over here, right, for the different possibilities. So let us list down the possibilities. So possibility number 1, the box will have 1 white, 1 black. Possibility number 2, the box will have both the walls white. Possibility number 3, so is there any other possibility apart from these 3, right? Yes, there would be one more, because the first ball white, second ball black, or the first ball black and the second ball white, right? These two will be 2 different cases. The first ball is white, second is black, or the first is black and second is white. These are 2 cases, right? So I have to make 4 different cases over here. So now we have these 4 possibilities. Now we will find out the answer for each of these possibility. Now this is one case. You are adding a white ball to every possibility, right? And then you are picking a ball. You have to find out the probability being white. But first I have to consider the probability of getting 1 white and 1 black. So getting this ball is white, the probability would be 1 by 2, because I know the ball is either white or black. For the second ball to be black, I need to find 1 by 2, right? So these 1 by 2 and 1 by 2 is the probability of having the first ball white and second ball black, because it is also not a sure event. It will also have some probability over there. So now you have added 1 white ball. So now the composition becomes 2 white and 1 black. So getting a white ball would be 2 by 3, right? This is for the possibility 1. Now the possibility 2, 1 by 2 for the first ball to be white, for the second ball to be white is 1 by 2. This 1 by 2 into 1 by 2 will always be there in all the 4 cases. Into, you have added 1 white ball, becomes 3 white. So 3 upon 3, that is the probability. This is half into half. You have added 1 white ball, so 1 by 3, half into half. You have added 1 white ball, sorry, 2 by 3, right? Because if you add 1 white ball, it becomes 2 white balls. Now we'll add all of these 4 values. Now the addition of all 4 of them would be my answer. So I can take half into half common. What is left inside is 2 by 3 plus 3 by 3 plus 1 by 3 plus 2 by 3. So this is 1 by 4. This is 2 plus 1, 3. 3 plus 3, 6. 6 plus 2, 8. So 8 upon 3. So we got 2 by 3 as the answer. So your final answer would be option B, that is 2 by 3. Right guys? So in such kind of questions, right, the most common mistake that kids do is they don't consider these two events as two separate possibilities. They think one is white and one is black is one possibility. No. First one is white, second one is black. First one is black, second one is white. These are two different cases and they should always be taken as two different cases. Right guys? So we are done with this particular example. Let us move and try the next example. Okay, so next example is way back. I don't know in 2003 whether you guys were born or not. I think you guys were born in 2003, right? Anyways, so 5 horses are there in the race. Mr. A select 2 of the horses at random and bets on them. The probability that Mr. A selected the winning horse. It's a very simple question, right? It's an easy peasy types question, right? That it can be solved down in 30 seconds. You don't have to waste time over here. So if I find out the answer, the probability of A. So now he has selected the 2 of the horses. So total possibilities would be 5C2, right? Selection of 2 horses out of the available 5 horses. Now this is 5C2. Now he should get the winning horse. Now out of the 5 horse, let's say H1, H2, H3, H4 and H5. Let's say H5 is the winning horse. So when A selected 2 of the horses, one of them has to be the winning horse. So the winning horse can be selected in only one way, right? That horse has to be there in our selection. Now out of the remaining 4, he needs to selection of 1 horse, right? That is your answer, simple. So 4C1 is 4, 5C2 is 10, 4 by 10 is 0.4. Do I see an answer over here? Okay, so I have a fraction. So 4 by 10 is 2 by 5, right? So 2 by 5. Option number 1 is the correct answer. Right guys, as I said, it was a easy peasy filler, right? So should not take that much of a time. Now this is one of the interesting problem that I have always observed as far as PYQs or probabilities are concerned. An interesting question, right? Now the question says a person goes to the office, right? Read it carefully. He goes to the office either by a car, scooter, bus or a train with a probability of 1 by 7, 3 by 7, 2 by 7, 1 by 7 respectively, right? Now there are many conceptual understanding from this particular example. Let me help you out. Now see, this person goes to the office either by car, scooter, bus and train. Look at their probabilities. 1 by 7, 3 by 7, 2 by 7, 1 by 7. If you add all these probabilities, the sum would be 1. And it has to be 1, right? Because the sum of all the probabilities should be 1. That is 1 over here. Now, what is the next statement says? Probability that he reaches office late if he takes a car, scooter, bus or train are the respective probabilities over here. 2 by 9, 1 by 9, 4 by 9 and 1 by 9. Now over here if you observe the sum of these 4 values, 4 plus 1, 5, 6, 7, 8. The sum is only 8 by 9. The sum is not 9 by 9 or the sum is not 1. Why it is not 1? It should be 1, right? No, it should not be. The question is absolutely correct. Because right now the question says if he reaches late, right? It's a probability that he reaches late by a car. Now reaching late by a car and reaching late by a scooter has no relation. Reaching late by a car and reaching on time by a car has a relation. So reaching late by a car, if it's 2 by 9, then reaching on time by a car is 7 by 9 and sum of these two would be 1. Over here, the person goes to the office. So he will take either a car or a scooter or a train or a bus, right? The sum of all these 4 will be 1, right? Exactly, Rishabh, right? He does not reach late every time. So the sum of these 4 will not be 1. Reaching late by a bus and reaching on time by a bus, the sum of these two should be equal to 1. So now it is also given that he reached office in time, right? So there is a condition that is given that he reached office in time. We have to find the probability he travelled by the car, right? So it is based upon the conditional probability or Bayes theorem, whatever you call it, right? So we will solve it logically without using the Bayes theorem or the conditional theorem. Now it says this event has already occurred, right? The guy reached office in time. So this has already occurred. We know कि ये बंदा office time पे पहुंचा ही पहुंचा है. If that guy has reached office in time, what can be the different scenarios in your sample space? So I am writing my sample space. He reached office on time. So either he took a bus and reached on time, took a scooter, reached on time, took a car, reached on time, took a train, reached on time. These are the 4 possibilities in the sample space. Apart from these 4, there are no other possibilities, right? So this will define your total outcomes. Why these 4? Because something has already happened, right? For example, let's say if there are 10 boys and 4 girls in my classroom, and if I say yesterday I went to a movie with a boy, what is the probability that it is Sita? Answer would be 0, right? Because I have already said it is a boy. So if something is given to you, it adds value to the probability, and probability is based upon the information given. So right now this is your total outcomes. So let us calculate. So he selected the bus. So let us first do for the car. For car it is 1 by 7. The selection of car is 1 by 7, and reaching time by car 2 by 9 is for the late. For reaching time it would be 7 by 9. Second, for the scooter being selected, it is 3 by 7, and reaching time with a scooter it is 8 by 9. Then third is bus. Selection of bus is done in 2 by 7, and reaching on time with bus would be 5 by 9. Train, it is 1 by 7, reaching on time by a train is 8 by 9. So I got all the 4 possibilities, and we have to find with the car. So this becomes your favorable, right? So all 4 will be your total outcomes. This is your favorable, and what is the probability? Favorable upon total outcomes. So now let us quickly solve this. So answer would be favorable is 1 by 7 into 7 by 9. I am not cancelling 7 because everything will have 7 into 9. So I will cancel all of them together. Denominator would be sum of all of them. Right? This would be the probability. So 7 into 9 will get cancelled out from everywhere. I will be left with 7 in the numerator upon 10 plus 24 plus 7 plus 8. 8 plus 7 is 15. 15 plus 10 is 25. 25 plus 24, that is 49. So I got 7 by 49, which is nothing but 1 by 7. So the probability is 1 by 7. That is my answer. But I have to find out P. So 1 by P is equal to 1 by 7. Right. So it is obviously P needs to be 7. Option number 3rd is the correct answer. Let us move ahead now. Okay, so now we have something on the Venn diagram. Okay, so now we have PA, PB, PC, PA union B, and so on, right? Now all these things I know they are connected with a formula which is P of A union B union C. The same formula we have also studied in the Venn diagram in set. In the Venn diagram we write in the terms of n, where n is the cardinal number, right? Over here we write in the form of probability. So what is the formula? P of A union B union C, right? There are 3 sets. It is PA plus PB plus PC minus P A intersection B minus P B intersection C minus P C intersection A plus P A intersection B intersection C. Right, this is the formula. Now let us see what all we got. A union B union C is alpha, so I can write this as alpha. This is equal to, what is PA? This is 0.6. Okay, so 0.6 plus PB 0.4. PC 0.5, P A intersection B. Okay, so I don't have A intersection B. We'll find this afterwards. So I am putting a question mark over here. B intersection C. I know B intersection C. Do I see B intersection C? Yes, it is beta. C intersection A. It is over here, 0.3. A intersection B intersection C. Do I have all the intersection? Yes, over here it is given 0.2. So I got everything except this A intersection B. Now for this A intersection B, we will use the second formula of probability of two events, P of A union B, right? Because if you observe, we have used everything except this. This is given to us, A union B. So I will use P A union B is nothing but PA plus PB minus probability of A intersection B, right? This is the formula for two sets. It is for the three sets. This is for the two set. So A union B is how much? 0.8. PA it's given 0.6. PB it's 0.4. PA intersection B is PA intersection B. So I can calculate from here and I can say P of A intersection B kitna aa jayega? 0.6 plus 0.4 is 1. 1 minus 0.8 is 0.2. So A intersection B is nothing but 0.2. So now I can write this as 0.2. So see, we got the complete expression in terms of alpha and beta, and we also know about the alpha, right? So we'll use this, right? So let us first simplify this expression. So alpha becomes equal to 0.6 plus 0.4 plus 0.5, that is 1.5 minus 0.2, so 1.3 minus 0.3, so 1 plus 0.2, so this is 1.2 minus beta. Now we have to find out the interval of beta. Okay, interval of alpha is given and we have calculated alpha in terms of beta. So now what I'll do is I'll put the alpha in the inequation. So let us write the inequation. Let us use a different color now. So it is 0.85 less than equal to alpha. What is alpha? 1.2 minus beta less than equal to 0.95, right? So now I will subtract 1.2. 0.85 minus 1.2 minus beta minus 1.2. So if I subtract 0.85 minus 1.2, this is how much? Minus 0.35 minus beta. How much is this? 0.2 and 0.5, so minus 0.25. Now multiply with minus sign. Remember, if I multiply with a minus sign, the inequation will change its sign. So now I got the range of beta. The beta ranges from 0.25 to 0.35. Now if you look at the options, 0.25 to 0.35 with the close bracket, yes. So this is how we have calculated beta, right? The question looks very, a very complicated or difficult one, right? देखते हैं तो वो ना monster वाली feel आती है, भगवान कैसे होगा ये वाला question. But if you observe, right, we have used nothing, just the two formulas, and both these formulas, each one of you knows, right? You have studied in the probability, you have studied this in the Venn diagram as well. So one thing that I always say to each one of my students, 100 times I say, do not judge a question by the way it looks, right? Because if it looks uncomfortable, difficult to you, it may not be the difficult. It can be a 5 second, 10 second, or a problem that can be solved out in 1 minute. So do not judge by the look of the problem. Try it. If you can't get it in the first 30 seconds, let's say if I read the problem and if I'm not being able to comprehend the problem, then it is difficult. Leave that, move on to the next one. If you can comprehend it, it's done, right? So now we move on to the next example. Next example says A and B are two events such that probability of exactly one of them occur is 2 by 5 and probability A or B occur is 1 by 2. I have to find the probability of both of them occur together. Once again, more of a Venn diagram but less of a probability. If you have observed in the last class also and in this class also, the questions that are being asked in JEE Main, right, they are not that difficult, they are straightforward, there is no much of a formula needed. You know all these concepts, but most importantly is you guys are scared, right? You guys are always have a fear of the examination and question. Be comfortable, trust on your preparation, that if you are prepared, then the preparation is with you and you can fight with each and every problem. So now over here I have two sets. Let us understand this. This is set A. Now after I am done with this solution, you will also understand what I am trying to convey, right? That don't judge the question by the way it looks. Two sets, right? So now A union B is what? Either A or B, right? Or let's say I write with N. So NA plus NB minus NA intersection B. Now, why do we subtract this? A union B is basically A, B, C, right? A should have this A, this B and this C. So when I take NA, NA will have A and B. When I take NB, NB will have B and C. Now you see, the element which is over here, which is common to A and B, has been counted twice, whereas B has to be counted only once. That's why we subtract B once, because we have to count B only once. B should not be counted twice. That's why we keep a minus sign over here. So now it says exactly one of them occurs. So exactly one of them occurs would be A and C only. I don't have to count B, right? Now in this expression, right, if I subtract once, B will be there. What if I subtract this twice? B will be eliminated, right? So I can say 2 by 5 is nothing but probability of A plus probability of B minus twice of probability of A intersection B. Is this clear or not? Why I have put a 2 over there? Because I need to completely remove A intersection B from the equation. What is 1 by 2? So 1 by 2 is union, right? So PA plus PB, that is your normal formula. What do I need? I have to find out probability of both of them occur. Matlab, I have to find out the probability of A intersection B. So A intersection B matlab this. So why don't we take the difference? If I take the difference, P and PB will be cancelled out. We are left with PA intersection B on the right hand side. So if I take the difference, it becomes 2 by 5 minus 1 by 2. This is equal to, this gets out, minus 2 plus 1. This is minus of PA intersection B. So from here I can say PA intersection B is nothing but half minus 2 by 5. So 1 by 10 is the probability. So 1 by 10 is, be careful, it is 0.1, not 0.01, right? So your answer would be option 4th over here. Right, so online exam 2017. Let us try this example now. Okay. So it says from a group of 10 men and 5 women, 4 members committees are to be formed, each of which must contains at least one woman. More of a PNC type problem, right, as compared to probability. The probability of these committee to have more women than men. Okay, fine. So more women than men. And how many members are there in the committee? 4 are there, right? So more women, 4, 0, 3, 1. If I keep 2, 2, it will be equal to 1, 3, men would be more. So these are the favorable cases, right? So, and total cases, so I'll find the answer directly, right? So we'll find the total outcomes possible. I have 10 men and 5 women. I have to select 4 members. At least one woman is there. So 10 plus 5, 15. I can select 15C4, right? So I merge the men and women together and I am selecting 4 out of them. Now there might be a possibility where all the selected 4 would be the 4 men, right? But the question says there has to be at least 1 woman. So I will subtract those cases where I have selected only men. Only men are 10. So 10C4 are the possibilities where I have got 4 men. So if I subtract 10C4 from 15C4, then I am left with all those possible cases where there is exactly at least one woman. This is total. So now I have to calculate the favorable. For favorable, these are the 2 possibilities. I will have 4 women and 0 men, or 3 women and 1 man. Select 4 women. How many women do I have? 5. So 5C4. Men is 0, so I don't have to care. 3 women. So 5C3. 1 man. 10C1. It's a AND condition, right? I need 4 people. So this would be my answer. Among the options, I have a fraction. So obviously I have to simplify over here. Let us quickly simplify this. 5C4 is 5, right? 5C3 is 10, 10C1 is 10, 15C4, okay, so let us calculate 15C4 separately here. 15C4, this is 15 into 14 into 13 into 12 upon 24, right? So 12 2s are 24. So I've got 15 into 7 into 13. Right? So we will also multiply these. 15 7s is 105. 105 into 13. So 105 into 13 is, this is 1300 plus 65. So 1365. Right? It is 1365. 105 into 13. Right, guys? So now we are left with 10C4 with a minus sign. Okay, so 10C4, let us calculate 10C4 as well. 10C4 is 10 into 9 into 8 into 7 upon 24. So 8 3s are. So now I got 210. Okay, so this is 210. How much I have on the numerator? 105 upon, this is 1 1 5 5 210. Yes, now you divide by 5. So this is 5 21s are, 5 2s are 10, 5 21 upon 231. Okay, so it is also divisible by 3. 7s are, okay, so 7 3s are 21, 77. 1 by 11. So upon simplification we got the answer as 1 by 11, that is option C. Right, guys? So this is the answer for this particular question. Let us see the next one. Okay, so now we have 12 identical balls, 3 identical boxes, probability that exactly one of the box contains exactly 3 balls. Right? Now why I have taken this particular example over here is to make you understand that in PNC, right, the distinct things, identical things used to make a difference, right? Because distinct and identical, the number of selection, the number of arrangements are different. When we talk about the probability, probability is always about the proportion. It is the number of ways in which something can occur, right? For example, let's say if I have 5 red balls, they are identical. The number of selection of a red ball would be 1. But the number of ways in which a red ball can occur or a red ball can be selected, right? The total number of ways are 5, but they are identical. So probability, we will take them as 5. In PNC, we used to take them as 1. So whenever you find out the problems on probability, when things are identical, I can give you an advice. Instead of identical, treat them as distinct and you will find your answer. Your proportion will always be the same. So now over here, I will consider these to be distinct boxes. One of the box contains exactly 3 balls. Now it looks exactly similar to the problem that we have discussed at the beginning of this particular session, right? So now I am writing the answer directly. Total outcomes. For the first ball, I have 3 boxes. Box A, box B, box C. Second ball, box A, box B, box C. 3. Third ball, box A, box B, box C. So for every ball, I am having 3 options. So it becomes 3 into 3 multiplied 12 times. So 3 raised to power 12 would be my total outcomes. Now favorable, one of the box contains exactly 3 balls. Now which of these boxes will contains the ball? Now identical, I cannot apply NCR in identical, remember, but now I have considered them to be distinct, because I know in probability identical and distinct makes the same number of outcomes. So 3 identical boxes, now I am considering them as distinct. So 3 boxes, I am selecting one box in which I will keep the 3 balls. Take 3 balls out of 12 and put in this particular box. Now we are left with 9 balls and we are left with 2 boxes. Now these 9 balls can be distributed in the remaining 2 boxes in any way, right? All the possibilities are allowed. So for the first ball I will have 2 options, for the second I will have 2, for the ninth I will have 2. So 2 raised to power 9 would be the total number of outcomes. Let us quickly simplify this. So 3C1 is 3, 12C3 is 12 into 11 into 10 upon 6 into 3 raised to power 12 and into 2 raised to power 9. Okay, so 1 2 gets out, this becomes 6, 1 3 gets out, 1 more 3 gets out, so it becomes 3 raised to power 11. Do I have any other 3? No. So I have a 2, 11, 10 I can write as 2 into 5 into 2 raised to power 9 upon 3 raised to power 11. So now this becomes 11 into 5 is 55. 1, 2, 9 becomes 2 raised to power 11 upon 3 raised to power 11. So this becomes 2 by 3 raised to power 11. Do I see an option like this? 55 into 2 by 3 raised to power 11. Okay, so I think there is a typing error over here. This 3 should not be here. Right, otherwise all the 4 options will be incorrect, right? And they show that we all are human, right? We do typing errors. This 3 should not be here. So your answer is 55 upon 2 by 3 raised to the power 11. Right guys, let us move on to the next example now. Now the next example once again has been asked in 2003 if you see, and once again being asked in 2013. So you never know, maybe it can be asked in 2022 or if you follow the pattern 2023. So there are 2 events A and B which are mutually exclusive. What do we mean by mutually exclusive event? Right? Both these events will not happen together. So the probability of happening of them together would be 0. Or in other words, if A has happened, B will not occur. If B has occurred, A will not occur. A intersection B, the probability would be 0. Right? So now it is also given that probability of A is this, probability of B is this. I need to find out what? Okay, I need to find the values of X and some options are given. Okay, so first of all, I know the probability for any event needs to be positive and a fraction. So first thing I know is it should lie between 0 and 1, the probability of A. Let us calculate X from here. Multiply by 3. Subtract 1, divide by 3, so I got the values of X over here from the PA, right? So I'll box it so that we remember. Now the second case, the probability of B, right? It should also lie between 1 to 4. Sorry, it should also lie between 0 to 1. My bad. So multiply by 4, you get 0, 1 minus X, 4. Subtract 1, right? Multiply with minus. If you multiply with minus, your signs will flip, right? So now I have solved that the probability should be positive. There is one more extra condition, remember, mutually exclusive. So mutually exclusive says PA intersection B would be 0. So I will find PA union B. What is this? PA plus PB minus P of A intersection B. And if it is mutually exclusive, this would be 0. So PA union B would be what? PA plus PB. What is PA plus PB? Let us simplify this. So if I take the LCM, it becomes 12x minus 3x, so 9x, right? 4 plus 3, 7. Now probability of A union B, is it 1 or should be a fraction, right? In the question, it is not specified whether A and B are the only outcomes. If A and B would have been the only outcome, this probability would have been 1. For example, head or tail. So happening of head or a tail would be 1. One of them would occur. But what if I take a dice, 1 and 2. So probability of happening of 1 and 2 will not be equal to 1, but it will be less than 1, right? So I know this will also be less than or equal to 1 and larger than or equal to 0, right? So from here I will get the values of x. Multiply by 12, subtract 7, divide by 9, so now my x should fulfill this, and should also fulfill this, right? So I have to take the intersection of all these three. Simple enough. Now for the intersection I will draw a number line and I will use the concept of number line over here. Let us draw a number line. So I am drawing a number line over here, right? So it would be visible. So now plot all these points. Make sure they are plot accurately on the number line, right? So I have minus 1 by 3 and 2 by 3. So I am putting minus 1 by 3, 2 by 3 would be somewhere ahead of this. 1 and minus 3. Okay, so 1 would be ahead of 2 by 3 and minus 3 would be somewhere over here. 5 by 9. How much is 5 by 9? It's a fraction. But 5 by 9 or 2 by 3? Which one is smaller? So 5 by 9 and 2 by 3. So I am going back to the class 6th, 7th. Have to compare these fractions. Multiply this by 3, this by 3. It becomes 6 by 9, 5 by 9. Which one is smaller? 5 by 9, right? So I know 5 by 9 is smaller, would be over here. Minus 7 by 9. So minus 7 by 9, and if I multiply this by 3, it becomes minus 3 by 9. So minus 3 by 9 and minus 7 by 9. Right? Cool. Right, so minus 7 by 9 would be over here, minus 1 by 3 would be over here. Now you plot minus 1 by 3 to 2 by 3. Minus 1 by 3 to 2 by 3. Second is 1 to minus 3. Okay, so I am having the complete interval. Over here minus 7 by 9, 5 by 9. Now I need those x which will satisfy all three of them. So in short, I need that interval where I have the overlapping by all three of them, right? It is obvious, you guys can see where is the overlapping, right? So my answer is x belongs to overlapping of all three. Close bracket minus 1 by 3, close bracket 5 by 9. So minus 1 by 3 to 5 by 9. Wonderful, your answer is option number 3rd. Right? This example is also clear to each one of you. Just stay with me and we'll have some more problem to solve. It's a very easy problem, right? A dice is thrown. Let A be an event, right? So this is an event. Number obtained is greater than 3. So A says a dice is thrown. Number obtained is greater than 3. So I know A is 4, 5, 6. What else it can be? B be an event, number obtained is less than 5. Less than 5 is 1, 2, 3, 4. 5 is not included, remember. Find the probability of A union B. So if I find the probability of A union B, now you combine them, probability of getting either 1, 2, 3, 4, 4, so I don't have to repeat 5, 6. So if I throw a dice, what is the probability that I will get either a 1 or a 2 or a 3 or a 4 or a 5 or a 6? Right? Silly question. Answer is 1. Right? Because if you throw a dice, one of these will definitely occur. Right? So I know the answer is option number 3rd over here. Right? So it was asked in 2008. Right? In 2003-4 we have seen such difficult problem. In 2008 you have found out these problem. Why I have taken this problem is because it is not necessary here that JEE people wants to ask a difficult question every time. All the 25 would be difficult. No, they do ask simple, straightforward, very simple question which a 6th, 7th, 8th grade student might can answer it. Right, so the next problem, this is completely Venn diagram, right? So try to understand this concept where I would be using a Venn diagram. Some events are given, I have been given some probabilities and I have to find out the probability of A intersection complement. This is complement, right? So now see how do we solve this. There are two events, A and B. So let us call these areas as A, B, C and D. Now see what all we know. The sum of all these would be 1 for sure, right? Charo ka sum 1 aana chahiye because this is the sum of all the probabilities. A union B is what? A union B is A plus B plus C. So I know A plus B plus C is 3 by 4. Right. Now we don't need to be a mathematical wizard to know that the value of D is 1 by 4. Right. Because A plus B plus C is 3 by 4 and A plus B plus C plus D is 1. So D has to be 1 by 4. So I got this value 1 by 4. Okay. Now A intersection B is given as 1 by 4. Wonderful. So B is given as 1 by 4 because this is A intersection B. So I also know what is B. Right. A complement. What is A complement? A complement means apart from A. Now A complement, so hide A, what do you see? C and D, right? So I can say C and D is the probability of A complement. Agreed guys? C and D. So sum of C and D would be how much? Probability of A complement, that is 2 by 3. But 1 second, I know the value of D. D is 1 by 4. So let's put 1 by 4 over here. And see what do we get? 2 by 3 minus 1 by 4. So now I have the C. Take the LCM. 12. 8 minus 3. Right? LCM 8 minus 3. Wonderful. So I got 5 by 12. That is the value of C. This is 5 by 12. So if B, C, D are known, I can easily calculate A. Let us calculate A. Put the value of C over here. I know C, I know B. So from here I will calculate the value of A. So A is nothing but 3 by 4 minus B 1 by 4 minus C, that is 5 by 12. So I take the LCM 12, that is 9 minus 3 minus 5. So I got 1 by 12, right? So now see, I got the values for each of these areas. Now whatever is being asked, I can easily find out if I know all these values. What is being asked? A complement. A complement will have A complement. Apart from A, what do you see? C and D. So A complement will have C and D. Intersection. What is there in B? B will have, this is the circle B, B and C. Now what is the intersection? This intersection, this. Intersection means common. C comma D, intersection B comma C. C is the common, right? So I know my answer will be equal to C. What is my C? 5 by 12. Done. So my answer is option number 1. That is 5 by 12. So with this, we come to an end of this particular session on probability. So PNC and probability, 2 chapters are down. If you haven't watched the PNC, you can watch it on our YouTube channel. Tomorrow at 3 p.m. I would be once again over here with yet another topic of algebra. Till then, stay safe and do subscribe our Telegram channel and the YouTube channel for all the updates and stuff. Right? Thank you so much guys. Enjoy your day and happy preparation.